Okay, so this is a cool little problem because it is a little counterintuitive and it can throw you off if you're not used to it. Somebody who is not sure about what's going on sees something like this and thinks, okay, log x base b equals zero point 0.9, so then I have to find what x is. But oh my god, what is b, right? And then if you're not sure, this could work, right? Trying to find that, trying to write that b to the 0.9 equals x, and then continue with y and z and do the same thing. That would probably work. Add the powers and whatnot. But the ideal way to do this is not that. It's to use properties of logarithms and then plug in those values to do some calculations with them. So here's what I'm referring to. The starting expression is the log b of a fraction. So whenever you have the log of a fraction, you can write this as the log of the top minus the log of the bottom. That's one of the properties of logarithms. Some books refer to this as the quotient rule. This is not the most common name for it. Most books won't have a special name as the quotient rule. Sometimes is a name used in calculus for derivatives. So here we are using this property where a division inside of the logarithmic becomes a difference between two logarithms, and now we have multiplication of two logarithms, right? Or multiplication inside of a logarithmic becoming the sum of two logs, and all base b, right? Don't forget. So this multiplication right here becomes a sum, whereas this difference here came from this division. So now if you're familiar with logarithms, you already know what we need to do now. We need to bring these exponents out, and the cube root of x is the same as x raised to the 1/3. So that is 1/3 log b of x plus this 4 comes out. That is another property that is sometimes referred to as the power rule, but for the same reason as the other one, that's not a very common name. It's a name that some books use. And then finally, you want to plug in the values you were given. So log x was 0.9. This is what makes it interesting, right? I have no idea of what x is, nor of what b is, nor y, nor z, but I know exactly what this expression is because I know their logs initially. Log y base b is 0.5, and log z base b is 1.2. Gotta be careful with your notation here, so your reader is not confused as to what is a decimal dot and what is multiplication. Now I just got to perform this multiplication. 1/3 times 0.9 is 0.3. 4 times 0.5 is 2. And then 1.2 times 5 is 6. Oh, this is just simple subtraction here. I have a -4 in here plus a 0.3. So that should be a -3.7, I'm pretty sure. Just double check with my calculator, because if this is a test, I don't want to mess it up. So I want to double check everything just to be safe. And it does look like I'm correct, and that is the answer to this question. I hope this helped.